trick actually works. Like I put in this nasty formula, just did this whole thing as y1, this whole other thing as y2. Just go ahead, calc, intersect, bada bim bada boom, you're done. You got the answer, and you barely had to do any math. You just had to graph it. Hello everyone. Welcome to what I think is the best calculator trick I have ever learned, and I hope it suits you well as well. Um, I mainly used this at the IB Math Studies level because it's when I could use graphing calculator. Later in university, I wasn't allowed to. But if you have a graphing calculator, like, damn, it can be overpowered. Like, these things are actually computers. I'm going to give you 3 examples. Um, of course, as you can see, they get harder each and every time. But the first example is just to explain like what the trick even is, okay? And so you have your graphic calculator, my trusty rusty T884, and you want to turn it on. You want to go to y equals, okay? And we'll clear what you got. And what you will ask the calculator is you will put half of the function as y1 and the other half of the function as y2. So what are you doing? You're doing 2 separate lines and you want them to equal each other. And so how do you make lines equal each other? Well, when they cross. Right where they cross is where they equal each other. Okay, so that equal sign over here, and if you graph it as lines, is going to be found where they intersect. Okay, and so if we put 120 for y1, this is to your discretion, of course, which one is y1, y2. And for y2, we put 4x. And the way I put x is by pressing the button right next to alpha. And we go ahead and graph. We end up with this, right? And you want to make sure that you can see both lines. In this scenario, I can, but something that can help you can do zoom fit, or just straight up go into the window and editing the window values so that it ends up looking prettier. Okay. And here it looks a lot prettier, but again, the only thing that matters is that both lines like show up. I just wanted to show the window stuff so that you know that it's there. It can be useful. You want to go to calculate, okay? And calculate is right above this trace button here. And so since it's a blue button for this calculator, you need to press second trace so that you hit calc, okay? Depending on your calculator, well, you know what up with that. You want to go to intersect, okay? You go to intersect. First curve is the blue one. Sorry. The calculator is asking which is the first curve, so you're going to pop it here. Which one is the second curve? So you want to make sure you are indeed in the second curve and not just the first one. Or if there are 3 curves, you want to make sure you're intersecting the right ones. And guess. So guess doesn't matter for now. That helps with parabolas or when they intersect more than once. It's asking you to guess where the intersection is. And so if there's 2 intersections, the guess function will help you nail the intersection that you want to obtain. And so we put it here and we have that the intersection is x equals 30 and y equals 120. So looking at example 1, it's telling us if y is 120, which is this guy here, then x has to be 30 if we're equaling it to this y. Because remember, this is my y1 and this is my y2. Okay, it's basically synonym for like lines. What really matters is that you know what you are asking the calculator, okay? And so and that gives us the answer for the intersection. So x has to be 30 to make this true, okay? And if we work it out, actually, just gonna show it real quick, divide both sides by 4, you can see that x equals 30. So that is just confirming that the calculator and the math is correcto. So now I will show an example number 2. So I went ahead and took the time to put this whole thing into the calculator. So here, even though it looks kind of wonky, you can still do the trick. So you want to go to Calc Intersect, even though it looks kind of weird. First curve is there, and the second curve, just go ahead and pop it. And it gives us that the intersection is 2.580. And so this would have taken like 4 million years to solve, but using the calc and intersect function and the y equals and stuff, you actually find that x has to be 2.580, and you do it surprisingly fast. Okay, and this is a lot faster than actually solving the problem. I guess if you're well versed with like exponents and stuff, you could do it quickly, but still, I feel like it's just way faster. You save a lot of time, and also, I mean, you're using the calculator. You're taking less risks, and this is the best calculator trick I know. That is a calculator trick. I highly recommend it if you're watching this because of my IB Math Studies videos. This one comes in especially clutch in the compound interest problems. I hope my emulator doesn't crash. But one thing that's important to show is that, at least for y1, it doesn't have to be like one value. Let's see if it works. We go ahead and graph, hope that the emulator doesn't crash. So we go ahead and graph. We end up with a really wonky looking graph. But nonetheless, we could get a intersect out of it. So we go second calc, intersect, first curve, second curve, guess. Bada bim, bada boom, we get a value. X equals 2.77. And so, well, this last example, and well, the second one as well, actually, it's a little different because um, the graph was probably like something like this, okay, and so, or it could have even there could have been more than one intersect. So I'm not showing all the intersects here, but it's important to show that the trick actually works. Like I put in this nasty formula, just did this whole thing as y1, this whole other thing as y2. Just go ahead, calc, intersect, bada bim, bada boom. You're done. You got the answer, and you barely had to do any math. You just had to graph it. I'm not saying graphing is easy, but if you get used to graphing, it's way easier than trying to figure out this math, because that's, dude, it just looks nasty. Like, come on. So if you're coming from my IB math studies, if you use this trick, you literally have to say, I mean, kind of like what I did at the end. You circle half of the equation and you say, hey, I put this as y1. The other one, the other half of the equation, I put it as y2. You write. It's very important that you write calc intersect and then the value that you got. Okay? But this is enough to show your process, and this gives you full credit. And I did this on the test, and I got full credit on the real IB test. Okay? So have faith in it. This is the best calculator trick I have ever used. I remember when I did it on the test, I used it for like half the problems, and it was legal. So don't even worry about it. And I think that's it. So I hope it helped. Get used to changing the window and the zoom and stuff. But Calc Intersect is the way to go, bro. I hope it helped, and have a nice day.